Hello, everybody, and welcome to this new episode of what we call the Factora Industry Webinars. For those of you who are not familiar with Factora, just a brief intro. Factora is an initiative that we launched last year through the IPSI Cloud. We coordinate that from Open Nebula Systems. It's a project through which we are defining, finally, a sovereign stack for AI in Europe based on the great open source technologies that are produced in the continent. So we're doing this exercise of mapping what's being produced, what's being developed in Europe that's relevant for AI, training, fine tuning, inference, and many other things. And trying to bring them together into something that makes sense that people, AI factories, but also individual companies or administrations can actually deploy and use for what are they need in a way that we help them also minimize their dependencies with non-European technologies and non-EU tech vendors. So I'm really excited because through this process, through these webinars, I hope we're also helping people discover or sometimes rediscover things that they knew about projects and technologies and companies that they knew, or sometimes they didn't know about them. So we're bringing for the first time to them these pearls. I like to call them these little or not so little pearls that we have in Europe, and sometimes we're not aware of that because of so many marketing campaigns from larger companies. But we really have amazing technologies, amazing open source companies in Europe that are producing things that sooner than later are going to be very, very important and critical for the strategic projects that we have in Europe, including, for instance, AI factories, or like today, turning edge devices and IoT devices into resources that can be used for running AI models. So today I'm very excited to have we have a company with whom we've been working for many years in a number of projects. So Phoenix Systems is a company that's based in Poland. They are the main developers and maintainers of Phoenix RTOS, the real-time operating system. They work with super cool devices, as we will see in a second. They are now leading these efforts also to turn things like energy meters and other kind of devices into infrastructure resources that can be used in sometimes for doing some really cool stuff in close connection with the data that's generated in that location. So we talk a lot about the AI continent, the massive investment in AI factories and gigafactories for training and all that. But many customers are what they are demanding right now is a secure way to execute the AI services and workloads closer to the devices, closer to the customers or the users. And this is exactly where smart edge IoT devices come into play. And it's very important that companies like Phoenix Systems, for instance, are working on the real technological foundations that allow these devices to meet those requirements. For instance, executing a small language model in a device at your home, for instance, or some other kind of model that helps you in your daily life, and you don't need those data, those applications to be running in a hyperscaler infrastructure. So, yeah, as I said, very very excited to have Phoenix today, Phoenix Systems, and specifically to have Kaya here joining us. Kaya is the Vice President and Chief Operating Officer of Phoenix Systems. So welcome, Kaya.
Hello. Hello, Alberto. Hi, guys.
And so really happy that you could make it. And obviously, my first question to you, Kaya, is it really sunny in Barso? Is
Yes, it
is
is.
that
It is
nice weather
early
in
summer.
Barso?
It is early summertime. Everybody is very happy to have this much of sunshine. It's almost like Spain, Alberto.
Almost. You should be outdoors. Actually, we should be having this webinar outdoors. This is the time of the year when you get some vitamin D, right? So,
Yes, definitely.
good. Okay, so Kaya, we've been working in different projects. We can talk later about your experience in EU funded projects and other initiatives. But the first serious question I have for you is, what's the history behind Phoenix Systems? Why the company was created? Why it has remained in Europe, which is always a challenge when companies become successful. Um, have you experienced the evolution of the company in these years?
Okay, so we are operating for almost 15 years now, and actually our core product, which is Phoenix RTOS, it was born out of a deep tech engineering vision to create this modern and scalable operating system that will fit on small microprocessors and could be scaled up to provide functionality of big computers to the small devices. So that was the vision behind the Phoenix RTOS at the beginning. So we chose the microkernel architecture at some point to provide this scalability. And we were always thinking about security of executions of applications at the edge. And I think this vision, we are continuing it through the years. There are some changes on the way. At some point, we came to the conclusion that open source is a good idea for us, because that wasn't the case at the very beginning of Phoenix RTOS. But at some point, we decided to do open source, and we are now present on GitHub platform. Over the years, we started to provide an advantage to our customers, which is reliability in critical infrastructure. We started in smart grid, in energy meters, data concentrator units, and gas meters. And nowadays, our technology is powering over 1.7 million devices across Europe. So I am personally very proud of that. And when I look at the engineers that created this technology, I feel humble. Then,
Very impressive. It's very impressive. Yes.
so, but that was this first kind of segment that we went into. And then we realized that indeed the energy segment, they need critical functionalities, and the infrastructure demands this reliability and security. So we thought that the same approach, the zero trust and deterministic architecture, would fit other markets. So we started development in aerospace, UAVs especially, and in the new space segment. Okay. I think I will talk about this a bit later, because these are very interesting use cases
very nice. Yeah.
For edge devices.
So you decided to work on some of the most challenging markets in the right, some of the most challenging sectors in the market. So very very critical infrastructure there, and high demands, regulation. Yeah, a lot of exposure to the end. I mean to the users, the citizens who use these devices and these services. Yeah.
Yes, but on the other hand, when you look at our core product, which is operating system, the more demands that you have from the market, the better we will utilize those demands to make changes in our architecture. So we can provide solutions for the future. Mm-hmm. So this is why those markets, we don't like to do an easy job. We always want to do the hardcore use cases.
Otherwise, you will get bored, right? We need new challenges coming, right? That's good. That's good. Nice. Probably, I mean, not everyone is used to work with microcontrollers. I mean, it's also from a technological perspective, it can be quite challenging as well. Working with an operating system, producing an operating system for these devices is also a heavy job. Would you like to do some quick presentation? Whether you, I mean, for a general audience that might not be familiar with this kind of devices.
So I prepared a presentation.
You're more than welcome to take the floor and tell us some more about this this very interesting world.
I have a short presentation about Phoenix systems. Wait a moment. Oh, there it is. Okay, so starting from who we are. So our board, which we all are, I would say we are engineers, but Marek is a programmer. He always says he's a programmer, not an engineer. Paweł Pisarczyk, who is our CEO, he was actually the original creator of Phoenix RTOS. Me with background in devices, in programming, but also in management, and Marek, whose background is also in embedded devices. We are based in Warsaw, Poland, but we also have an office in Łomża, also in Poland. This is our testing facility because when you're working with multiple architectures, you always need like a lot of hardware where you automatically test any change in the operating system or frameworks that we also provide. And nowadays, believe it or not, we have 50 plus engineers working on our projects, which makes me personally really happy that the team grew so big. We've been 15 years on the market, and we think that we are a deep tech entity at this point because we go really deep into the technology, into the software stack. And what we try to do is answer the problems of today and tomorrow. As I said, we target those very difficult sectors with demanding requirements. We want to meet them, to change architecture of our RTS, to continually advance it, to meet those requirements of tomorrow. We are present in smart grid, where we have 1.7 million devices, but we are also in defense and space markets. We still want to continue to develop our product and our offer. We are currently invested in development of autonomous vehicles, mainly an autopilot for the drones. We do collaborate with a lot of entities from Europe, for example, with Open Nebula, and we are very proud to be able to collaborate with you. And we are now more than 50 engineers and programmers. So we started from smart grid in terms of how we went into devices and proved that this concept of a new RTS is valid and is needed. Then we started to work on Phoenix Pilot, which is autopilot ready for commercialization now, and it is a dual-use application. Thanks to participating in IPSAC's project, we are developing our own CubeSat, which is a platform consisting, of course, of hardware, but mainly of a software that showcases how you can define by software the functionality of a satellite, including AI on board on a satellite. We are also present with our vision in industrial IoT, where we are developing a sensor box, which is an IoT computer to gather sensor signals and do predictive maintenance. As I said before, the road was not clear at the beginning. We started from microkernel at the beginning, but that was the thesis of Paweł Pisarczyk, the master thesis. Then we went with the architecture to a monolithic kernel. But when we gathered all the requirements from smart grid sector, we realized that was not a good idea. We went back to microkernel, and this is the architecture that we utilize now. To show you that this is not a simple solution and simple operating system, you can see the console view. It looks like you would be using a Unix-like system, right? But also you can have X Windows, which you can see on the top. Why is it easy to use Phoenix RTOS? It's that we provide, in addition to microkernel architecture, we have a POSIX compliant interface. So at the end, we provide the solution that is hardware agnostic. It allows the flexibility. It allows developers to deploy code across both heavy MMU-based application processors and tiny MPU-based microcontrollers. Where do we position ourselves? We saw, maybe not from the very beginning, but for a couple of years now, we saw this niche in edge IoT operating systems. We have small embedded OSs that are widely used and they are needed. On the other hand, we have desktop OSs, somewhere in the middle, mobile phones with iOS and Android. And what we see is growing now. It was needed a couple of years ago, but now it is growing, is edge IoT operating systems. These are the systems for devices that provide the main functionality that operating system provides, which is an execution environment for application that is hardware agnostic, that allows this flexibility and allows to move applications from one device to another device without changing the code. So it moves the edge IoT device from the bare metal concept to the operating system concept. So far, with our partners, we have developed a range of products. And historically, we started with the DCU device, which we are still providing with Polish company Apator. This is the device that you use on the substation, and it has dual functionality. The first functionality that it provides is the energy meter, because it has to measure the energy going out and into the substation. But the second functionality, which is also very important, is that this device is communicating to customer meters to gather energy consumption and production values from those meters. So currently we have 67,000 of those devices being implemented at customers in Poland, and they are gathering data from 3 million energy meters. Then the second implementation that we did was gas meters, that is also with Apator group from Poland. First implementation was only 20,000 devices, but with the architecture that we provided, we enabled our partner Apator to go into wider market and provide platform for Belgium, for Poland. We are working in Spain as well. So overall, over 1.6 million gas meters are working in field or will be soon working in field with our Phoenix RTOS. And they are communicating through narrowband or WM bus. We have the same concept for defense segment. We developed our own Phoenix pilot, and now we are in the process of bringing this Phoenix pilot into market with our partners. You can see the drones that are also nowadays using our system and autopilot. Hopefully soon you will see a lot of them flying around. And the other thing that we are currently doing is development on environment which is meeting the requirements of the 178C standard. What is important or maybe interesting is that all of those devices here, the drones, they have NPUs, which are AI small AI accelerators, so they're able to detect, for example, a human or a car or a target. Last but not least, space segment. We are now developing first CubeSat with Phoenix RTOS. We are basing it on space-grade components. But what we want to show is software-defined architecture. For example, instead of using a separate ADCS system, which is basically a system that positions satellite in space, we have developed an application that is running on top of the system, and this application is performing this ADCS functionality. We do provide Edge AI support, and next year we want to test the satellite in space conditions, so it will fly into LEO orbit, and we want to demonstrate over there the fire detection through processing vision algorithms. Our next step would be, to do satellites that will be based on commercial off-the-shelf components, so they will be much cheaper, more advanced in terms of functionality. What we want to provide over there is to have software hardening. So instead of buying space-grade components that are really, really expensive, we will provide this software-defined reliability. So the software will decide if the component is okay or not, or should the decision based on component A or B, because there will be like 3 of them. I think that is all in a nutshell. Probably took too long time, Alberto, sorry.
It's fine, Kaja. No, you guys are doing really cool stuff. I think it was worth taking some extra minutes to explain, because I think it's very interesting, that transition that you're doing from the energy sector. It's, as we've mentioned before, it's very demanding as well to other two sectors that are also very peculiar. So
I think we all know pretty
congratulations
well,
on that.
we all know very good what happens when energy sector collapses, when
Mm,
suddenly you don't have power. That's why all the devices have to be working very well. You don't have this space to make an error.
yes, yes. Well, we have a blackout in Spain a few months, some months ago. You remember that, right? But it wasn't the meter, so good. I mean, I guess resilience in the sector is built up from the basis. I mean, the whole chain, right? Including, I mean, every single device, every single connection there, network has to be secured. So yeah, I think you play a very interesting role in that way, making sure that the meters are secure, but also, as you've shown, that you're always expanding the features, right, of the operating system, and then in turn of what the devices can themselves do, right? This thing that you mentioned about the devices that are able to collect data and metrics from the consumers, and then produce I mean, deploy this kind of intelligence also for the operators of the network in the substations. I think that's really cool. Yeah.
Thank you.
I mean, I was wondering, you've mentioned the IPSI cloud. I know you guys have been involved in other projects in the Horizon Europe, for example. So for a company of your kind, I mean, working with an open source technology that you are the main maintainers, that you are developing through different projects, different initiatives. What kind of what's been your experience with these projects? What kind of things, what kind of support you could be getting from the European Commission, for example, when it comes to making it easier for a company like Fenix Systems to participate in these projects?
I think what open source does for us, it is that it has the ability to foster transparency and collaboration. You cannot hide anything if it's open, but then you can talk about it. You can talk about new ideas.
Mm-hmm.
You can implement them together. You can adapt, learn. I would say there are more advantage of open source than one would think at the first glance.
Mm-hmm.
That helped us over the years, especially with working with European Union Commission on the EU projects,
Mm-hmm.
but also to foster this collaboration uh, within EU with a lot of companies.
Mm-hmm. And I guess also, I know it was your case, but sometimes in these programs, in the side, some of the companies discovered that they have other companies in the same country that they didn't know that well, and these projects also help them to foster these new collaborations with literally their neighbors. So I don't know if that was the case.
Yes, exactly. This is the case, but this was the case, but this is the case still. What IPSI formed, from my perspective, is this environment where even if we are at the end of the project, we still are finding new collaboration within IPSI CIS.
Mm-hmm.
Because at some stage of the project, maybe it's easier to explain the project, or maybe it's easier to find common points.
Mm-hmm.
But we see that even now, after this couple of years, we are forming new collaborations and
Mm-hmm.
creating new projects that are like spillover from the like nowadays old ideas.
Mm-hmm. Yeah, and also, I mean, your technology changes in the meantime. You also adapt to you get new challenge. I mean, new requirements, new challenges, and that, I guess, that helps also.
Maybe
Uh,
this is evolution of technology.
yeah, I guess. And well, I assume, well, energy is one of those sectors where this concept of sovereignty has its own meaning. There are its own discussions about what it really, what it really means in practical terms. But I'm very interested in your perspective, because you have this experience in a sector where also sovereignty is very important, energy sovereignty. Then you're also very familiar with what's going on, all the debates about technological sovereignty in Europe. So my final question to you was to understand a bit more what's your perspective on this debate. How do you see, and specifically, how do you see the role of European open source in building this technological sovereignty in Europe?
Well, first of all, I think a few years ago it was a buzzword, but I feel that now it's not, finally, which makes me really happy. Because what sovereignty means, it means to have control over your stack. Going back to smart grid, it means to have control over not only software but also hardware, to know where it's coming from, to have a supply chain that is clean. That is also true for software and hardware. That we want to have the supply chain that is free from black boxes, especially third-party black boxes. Because if you don't know what is inside and how it works, then you don't know if you are safe and secure. You don't know if you are going to, if you will be able to continue your business as you do today. And in terms of critical sector, and the energy sector is a critical one, you cannot afford not to be sure you can continue your business tomorrow, because that would collapse globally the economics. So we are thinking, yeah.
No, I mean, and I was going to say, I mean, you guys work with also very sensitive data, right? I mean, all the data that goes through your devices. I mean, I'm thinking about consumption data. These metrics, it can be used to understand patterns, or when a house or a company or an embassy or whatever is empty, or this kind of thing. So, I mean, there are also kind of implications in physical security when someone might have access to those data, right? Those.
Yes, we do have to follow the requirements of physical security, but more importantly, in my opinion, the cyber security.
Yeah.
Because we need to be sure that there are no backdoors. Also, from the GDPR perspective, what you said is true. Those data are GDPR protected, the data from the meters. So we have to be very careful and have to have a secure chain to process this data.
Yeah. And speaking of hardware, you've mentioned, I mean, I've shown before this new smart meter that you guys have been working on, and that makes me wonder, how feasible do you see the adoption of more European hardware devices at the edge when it comes to facilitating AI? Because the expectation is that European hardware manufacturers, those working with on accelerators, they will be able to supply also these chips to more devices at the edge, IoT devices that in turn will be able to process some of these workloads and this data. Do you think that's the natural market for these hardware manufacturers to try to bring their platforms to the edge?
I think so. In future, it will be the market. I think first of all, it will be the market for the small energy communities, because they will actually gain a lot from managing their data, including using AI on the meter itself. In terms of whole market, there are a million devices that need to be exchanged
Mhm.
in the European Union. This is a massive project. So, on looking at the big picture, the first transformation that is happening now is to have those meters connected.
Mhm.
Then we will see slowly coming the second transformation that will start to use AI. Nowadays, we are closer to using AI in defense sector, for example, which is also pushing on sovereignty.
Mhm.
One would say obviously, but it was not that obvious a couple of years ago, I would say.
Mhm.
Uh, and over there, it will be used, in my opinion, much sooner. It is used already, um, but the scale will grow more rapidly.
Okay.
And in
And in
terms
some way, I mean, Poland is an interesting market to try those new devices, right? I mean, the defense sector in Poland is very active for obvious or not so obvious reasons, but
it's hard to hide our geopolitical location, right? So yes,
you're literally
uh,
at the front line of these innovations. Yes.
we are at the front lines, but here it is very much visible that uh, European IP, 100% European IP, is needed and valued.
Mhm.
That at the end, this is something that will empower manufacturers
Mhm.
to move forward with technologies, not only software technologies, but all technologies in general, that this will allow the manufacturers to go globally with those
Mhm.
technologies, because uh, the 100% European IP is something that will allow you not to be subjected to, for example, US ITAR restrictions
For
uh,
export.
or hardware lock-ins,
Mm.
right? So, in this sense, it is very much needed, and it's not a buzzword, it's a tool that empowers.
That's great. That's a great message, Kaya. Thank you very much. Okay, so I think that was great for a quick catch up on the on what you guys are doing. Well, thank you very much again, Kaya, for joining us for this webinar, and congratulations and thank you for the work you guys are doing. Um, I'm sure that well, sure people will be willing and really to follow up after this webinar and to know more specifically about the I mean, how you're working on turning these devices into AI inference devices as well, and the work you guys are doing with drones. That's actually really nice. So I hope this webinar will help people discover or rediscover what you guys are doing. So thank you again for joining us.
Thank you, Alberto. Goodbye.
And then from my side, just a quick reminder that we are producing this content in collaboration with a couple of EU-funded coordination and support actions, NexusForum under the Horizon Europe program, and CISERO project, the exploitation office of the IPSAI cloud, under the Digital Europe program. So also thank you to the Commission for funding these projects. And that's all for today. And thank you again for joining us. And see you in the next episode. Bye bye.